Year 11, we're going to go over variance and standard deviation. And we're going to relate this to our probability distributions. But before we do that, we're going to have a quick look back at what variance and standard deviation are. Now, when we talk about data, we talk about the measures of central tendency, so our mean, median, mode. And we also talk about measures of dispersion, so the range, the interquartile range. But one of the best measures of dispersion is our standard deviation. Now, how does this standard deviation come around? So if you think about it, we want to find out how things are deviating from the mean. So how is a score, how are all the scores deviating from the mean? So if you take a score and minus the mean, you'll get a deviation from the mean. So let's say you had a score of 70 on a test and the mean was 60. You go 70 minus 60 and you get 10. You're 10 units away, but there might be someone who got 50 on the test. And you go, oh, how does that? Well, 50 minus 60 gives me negative 10. It's still the same deviation, like it's a deviation of 10, but how do I account for that negative sign? Well, one way to do that is to just take the absolute value. And that will get rid of that negative 10 and just leaves me with a deviation. And that's good, but it's hard to try and use that. The other way to get rid of that negative is to square. So here I get 70 minus 60. I get 10 and I'd square it, so I get 100. And over here, I get the same thing because negative 10 squared is 100. And that would get rid of the negative sign. And that's what they're doing when they calculate the variance. So they take every score in a set of data, every bit of data, they minus the mean, they square it, they add them all up and divide by the number of scores, and that gives you the variance. Now, the variance is good, but you have to realise that you're talking about squares of the original unit, and that's not good. So what do? They square root it, and you get what we call the standard deviation. So how does that work? Let's have a look here. And if you can see here, got a set of scores, 12, 9, 6, 5, and 8. They calculate the mean, and you can't see it over here, but the mean is 8. Then they go, all right, 12 minus 8 gives me 4. Square that, 16. 9 minus 8, 1. Square that, 1. 6 minus 8, negative 2. Square that, 4. And you get all these, and then they add them all up, and you get 30. And you go, oh, 30, get out of there. 30 divided by how many scores? 5. That'll give you the variance. If you did 30 divided by 5, the variance is 6. But you want that not in squared units, so you square root it and you get 2.49. That is how we calculate standard deviation. Now, how does that relate to these probability distribution tables? Well, remember, if you remember back, and I'm just going back to these exercises because a few practice sets, we already have calculated in a probability distribution table the expected value or mean. So we did that back here. I just want to revise this because we need to remember what we're doing. So the expected value or mean, we represent E of x. And how do you calculate that? Well, it's essentially the mean, but you're using the probabilities. And the expected value is the sum of all the scores, look down here, the sum of all the scores multiplied by the probability, and it gives you the mean. So it's important that you remember what we're talking about when we talk about expected value. And remember, when we're talking about discrete data, we're using Greek symbols. Later on, when we talk about continuous data, we'll use, when we talk about samples and populations. When we're talking about populations, we use the Greek symbols. When we're talking about samples, we'll use the English alphabet. So, and you did all that work there. Now, there's a couple of formulas here, and they look really difficult, but they're not. So, let's have a look at the first one, variance. We already know that. So what are we doing when we do variance? I'm just going to create some space for myself here and get rid of that. Okay, still got this down here. So the variance, you already know what you're doing with the variance. You're adding up all the scores. See how you've got it here? Adding up all the scores minus the mean, squaring it and dividing by the number of scores. Well, now we're using a probability distribution table. That just means you can find the expected. So you add up all the scores, square it, and multiply by the probability. Right? Because the probability is our frequency. Remember, we're doing this with a probability distribution table. So we minus the mean, square it, and multiply by the frequency, which in this case is the probability. And we add all those up. But another way to do it is to find the expected value of all the scores minus the mean all squared, because that's what expected value is. Do you remember? Expected value was the scores times the probability. So these two things are exactly the same. They're just different ways of calculating it. Now, to calculate the standard deviation, all you got to do is square root it. Square root the variance. And then finally, they put them all together and you can have these three methods. Now, look at this bit here. You can just find the expected value of all the scores squared, right? And then minus this, the mean squared. How does that work? Well, have a look here at this proof. So we already knew this, the variance. We can expand this because we know the expansion of x minus u all squared. And notice that they've put a p of x multiplied by each one. So you get x squared minus 2u mu x plus mu squared. Now, well, that's pretty obvious. That's just the sum of all the scores squared. That's the expected value of all the scores squared. Can you see that? That's the sum of x squared times p of x, which is just that. Now watch what happens here. Well, that 2u is a constant. So you can take it out of the sigma bit. The same as I can take that u squared out. U is a constant. So it's like factorising it out. When I take that 2 mu out, once I take that out, I've got x times p of x. Well, x times p of x, the sum of all that is the expected value, it's mu. So you get minus 2 mu times mu, which is negative 2 mu squared. Now over here, if I take mu squared out, I'm left here with p of x, the sum of all the p of x's. Now we know in a probability distribution table that the sum of all the probabilities is 1. So that becomes mu times mu squared times 1. So I'm going to have, and they've left a line out here, minus 2 mu squared plus mu squared, which leaves me with minus mu squared. That's the proof. You don't need to know it. You get these on your formula sheet. On your formula sheet, come here. If I go to Year 12 Maths Advanced, I'm pretty sure I've got the formula sheet somewhere here. Where is it? Trig with radians. HSA. I haven't got last year's. It's on your formula sheet. You will see it. So let's go back. Here we go. You get a whole lot of different ways you can do this. So if they give you a probability distribution table, you can, say for example here, go 1 times 0.6, 2 times, all those probabilities, add them up, and you'll get the mean. And then if you square all these, times them by the probabilities, and at the very end, subtract the mean squared, you get the variance. And then if you square root that, you get the standard deviation. The other way, because there's another example here, calculate the mean, calculate your score minus the mean and square each value. So that minus 1 minus the mean, or the expected value, squared, 2 minus the mean, and then multiply by the probability, you get the same result. And then you square root it. So, in the end, you're going to do these with your calculator, but it's important that you have a couple of goes at doing it the normal way. Now, it's really funny because they tell you to work out the standard deviation first. Really, you've got to find the variance first and then find the standard deviation. So, if I do question 1A, so here we go, let's have a crack. 1A. I have to calculate the expected value or the mean. And remember, that's pretty easy. It's just 1 times 0.17 plus 2 times 0.24 plus 3 times 0.12 plus 4 times 0.13 plus 5 times 0.23 plus 6 times 0.11. And you'll work all that out and you'll get 3.34. Now, you need to calculate the second part. Well, we haven't even done it yet. 1A, we've got to now calculate the variance. So the variance of x. And remember, you can do either way. But I'm just going to take the easy way, which is this one. That's the easiest way. Right? Calculate the expected value of all the squares and minus the mean squared, or the expected value squared. So the variance is going to be 1 squared times 0.17. 2 squared plus 2 squared times 0.24 plus 3 squared times 0.12 plus 4 squared times 0.13 plus 5 squared times 0.23 plus 6 squared times 0.11. Oh, hold on. Minus this squared, 3.34 squared, because I've got the expected of the squared minus mu squared. And that's what the variance is. And if I calculate that all up, I get 2.8. I'm looking at the solutions, but I've got exactly the same thing, 2.8514. And then to get the standard deviation, lowercase sigma, I square root 2.8514, which gives me 1.69. All right. So it's quite interesting that they've asked for the standard deviation first and then the variance. Well, no, it's not if you know how to use your calculator. And this is where it gets really useful. So if I just get my calculator open. So set your calculator up, put it on stat, and you're just going to go one normal variance, but you need a frequency. Now, if you don't get a frequency column, you need to have one. So I'm going to go Shift, Set Up. I'm going to use my arrow to go down. I'm going to number 3, and I want my frequency on. Now, all you have to do is put the numbers in, and what were they? 1, 2, 3, 4, 5, 6. Go across and put the probabilities in. So 0.17, 0.24, 0.12, 0.13, 0.23, and 0.11. Once you've got them all in, press all clear, go Shift, down here, Stat. Oh, come on, get out of there. Didn't press the Shift properly. Shift, Stat. I want my variable statistics. Now note here, when you get these, you get N. N tells you how many scores. All right? 2, X with the dash, that's your mean. All right? Then you have 3 and 4. Now 3 and 4 are both standard deviations, but 3 is a population standard deviation, the sigma, when we talk about populations, whereas 4 with the English letter S is the sample standard deviation. And at this stage, we're not using sample. In fact, never use it unless the question specifically states sample standard deviation. So remember, we did the expected value was the first thing we calculated, and it's there beside the calculator is 3.34. So let's double check and make sure we're right. And there it is, 3.34. So all that work you did, your calculator can do it for you, but you need to understand what you're doing. The second thing, and this is why they've asked for the standard deviation first, is because your calculator does it. So if I go Shift 1 back here and get into that data, I want number 3. Now we already know what the answer is. It's 1.69. And there it is, 1.68653449, there I know. And how do I get the variance? I just square my answer. And you get 2.8444, which is slightly different from the variance that we got when we did it doing that other method. All right? So you can use your calculator, but you've got to know the method for calculating each of these. Now, none of these questions are hard, and there's only 10 of them. So I'll just do the last one and see how you go. So in a game, 2 cards are drawn from a deck of 52 standard cards. A player wins 5 points if one of the cards is an ace and 10 points for a double ace. If the random variable X is the number of aces drawn, create a probability distribution. Okay, so let's go. So we need to make sure we get all these things in. So I need to find out the probability, and I'm drawing 2 cards, of getting an ace. So here we go. So X, P of X. I can get no aces, I can get one ace, I can get two aces. Well, I need to work out how this is going to work, how I'm going to get this. So I'm going to draw a quick tree diagram. So am I replacing these cards? Two cards are drawn from the deck. I'm assuming non-replacement. I'm assuming non-replacement. So I can either get an ace or not get an ace. And I can either get an ace or not get an ace. I can either get an ace or not get an ace. Now there are four aces in a pack. So 4 on 52. And that's going to be 48 on 52. Once I've drawn an ace, there's only 3 left and there are 51 cards. There's still 48 non-aces there. And here, there are 4 aces, 51, and there are 47 on 51. So let's calculate all these probabilities. So I'll need my calculator. So, and I want it as a fraction, so I'm going to do all this as a fraction. Because I'm in stat mode, so I'll have to go to my setup, put it back on computation. Okay, so now 4 on 52 times 3 on 51. Oops, put in another fraction. 1 on 221. So over here. So to get 2 aces, it's 1 on 221. I'm going to keep my calculator in that mode, and I'm just going to go back and change that to 48. I love the back. 16 on 221. So ace and not an ace. 16 on 221. Let's go back, get our calculator and go back again. Right, I want this back as well. Right. Now I want 48 on 52 and 4 on 51, 16 on 221. I should have known that because it's just a reverse order of the other things. So 16 on 221. And the last one, I want 48 on 52 and I want 47 on 51 and 188. So of not getting 2 8s, 188 on 221. So now over here, what's the probability of getting no aces? Well, that's easy. 188. Oops, sorry, my writing's gone terrible. 188 on 221. To get one ace, well, to get one ace, that's both that one and that one. So 32 on 221. And the last one, 2 aces, well, that was 1 on 221. Now, for this to be a probability distribution table, all those probabilities should add up to 221 on 221 or 1. And if I add those up quickly, like, yes, they do add up to 1, so I'm all right. So, create a probability distribution table. Done. Find the mean and variance and standard deviation. Okay, so I'm going to do this manually and then I'm going to check on my calculator. So, the expected value equals 0 times 188 on 221 plus 1 times 32 on 221 plus 2 times 1 on 221. And that's going to give me 34 on 221. I'm pretty sure. Get my calculator. 34 divided by 221. 0.15, and that's what they've got in the back of the book. I prefer it as a fraction because it's in the back of the book they've got, or in the work solutions they've got 0.15, when really it's 0.1538 and it goes quite on. And if you start using rounded versions, you'll run into trouble. Now, to calculate the variance, remember the variance? Okay, so the variance, I have to square them and times the probability and then minus this thing squared. So 0 squared times 188 on 221 plus this thing squared times 32 on 221 plus this thing squared. Sorry, I've squared it already. And then I've got a minus this thing squared. Now I'm going to need my calculator for this. I'll just keep it as fractions. So that's going to be 0, that's going to be 32, that's going to be 4. So I'm going to have 36 on 221 minus 34 on 221 squared. So I've already got that, my answer squared. So I'll just go 36 divided by 221 minus my answer, because it was already in there, squared. And it's 0.139. The back of the book's got it as, or the work solution is 0.14. So equals 0.139. Let's be a bit more exact. 2272885, I think. And to get the standard deviation is the square root of that. So I square root my answer. 0.373137. 0.373137. 373 And the answers, they got 0.373. Who would do it that way when they have this function in their calculator? So here we go. Just go set up, put it in stat, go 1. You got your frequency on now. You can get 0, 1, 2. That's all you can get. Go over here. What are they? So just go up here to my probabilities. And you can write them in like this. So 188 divided by 221. It gives it as a decimal. 32 divided by 221. And 1 divided by 221. Once you've got all of them in there, all clear, go shift, stat, get your variable data. You want the mean because that's the expected value, so number 2, 0.15. So here we're coming down here. Remember, 0.15 is right. Now, I'll get the standard deviation. So we go shift, stat, number 4. We want the population standard deviation, number 3. Away we go. 0.3173, that's exactly what we got. And to get the variance, we will just square it. And there we go. So when you're doing these questions in the HSC or in your exams, you need to be able to do them. I'm not going to do B. You can have a crack at that. The work solutions are pretty easy once you go and have a look at that. But once you'll be able to use your calculator for most of these. All right. Anyway, good luck with those.